is depends on current, voltage and travel speed, but the heat input is mainly influenced by the travel speed. For example, if your travel speed is fast means the heat input will be low. It will lead to sudden cooling, so higher hardness and then lower toughness, small grain structure, material will become martensite. Okay. If your travel speed is slow, if your travel speed is slow, means the heat input will be high, so hardness will increase, toughness will decrease, large grain structure, higher distortion, higher distortion. So very important. Okay, the previous chapter we already discussed. With most welding process, the welding in the PA flat 1G position gives highest productivity. Flat 1G position gives highest productivity and highest fume inhalation also. Highest fume inhalation also. Okay. The rate of molten metal transfer. The rate of molten metal transfer to the weld pool is the deposition rate, which is directly related to the welding current. The deposition rate is based on your current. Okay, sorry, it's based on current density. The deposition rate is based on the current density. For example, approximately 35 amperes is required for 1 mm of dia of the electrode. 1 mm dia of the electrode is required 35 ampere. Okay, let's come to the heat input. What is the heat input? The arc energy is the amount of heat generated in the welding arc per unit length of the weld. This is the heat input. The unit is kilojoule per mm. We can expect the heat input. What is the unit of heat input? The answer will be kilojoule per mm. Okay. Actually, the heat input formula, we have to calculate the arc energy first. The arc energy is voltage multiply ampere divided by travel speed. The travel speed should be mm per second. In your questions, they will give mm per minutes. In these cases, you have to convert it to seconds. So you have to do divided by 60 in your travel speed. Okay. The multiply 1000 is the kilo. So the purpose of the kilojoule, so you have to multiply with 1000. Okay. And in your question, the travel speed they will not give directly is a travel speed. They will give sometimes is a run out length. Sometimes it will give they will give a run out length. So run out length means it's a travel speed. For example, what is the run out length? I am having two same size of electrodes. I am having two same size of electrode. For example, this is the 30 mm length. This is also 30 mm length. This is the 30 mm length of the joint plate. By using this 30 mm length of electrode, if I complete the welding, for example, how much mm I am completing the weld? That is the called run out length. Okay. Sometimes they will ask the shorter run out length means shorter run out length means what is that? It's a slow travel speed or fast travel speed. Shorter run out length means it's a slow travel speed or faster travel speed. Yes. For example, the 30 mm length of weld by using the 30 mm length of welding by using this one, I complete 30 mm length. Okay. The same size electrode, if I complete 15 mm or 10 mm means it's a shorter run out length, it's a slow travel speed. So shorter run out length means it's a slow travel speed. The height input will be high, the toughness will be less, hardness will be high. Okay, so we can expect they never give the faster travel speed, weld made with faster travel speed, weld made with smaller travel speed. They will never give like this. They will give only run out lengths. And or else sometimes they will give excessive weaving. Excessive weaving means this is the weaving. Listen, my friend. This is the weaving. The weaving. Okay. Excessive weaving. The excessive weaving means it's a slow travel speed. Excessive, as per the WPS, if you are doing excessively weaving means it's a slow travel speed. So heat input will increase. So they can ask the question excessive weaving or short out run out length like this. So you have to, whenever you get the question like this, you have to link with travel speeds. Okay, next. Okay, the heat input is the energy supplied by the welding arc to the workpiece. Heat input, arc energy multiply thermal efficiency factor. Arc energy multiply thermal efficiency factor. Okay, so arc energy we can calculate by using voltage, ampere and travel speed. So heat in for heat input we have to multiply with arc energy and thermal efficiency factor. The thermal efficiency factors, the values are constant. Thermal efficiency factor values are constant. For example, the SAW 121. 121 is the welding process number. Sometimes they will not give SAW, they will give 121. So 121 means it's a welding process number. The 121 is the SAW. Okay, it's the heat input is the thermal efficiency factor is 1. That's why SAW is the highest heat input welding process. The last chapter we studied. Okay, so it gives highest heat input and high productivity, and it gives deep and narrow weld profile. Okay, MMA covered electrode 111. 111 is the welding process number. The heat input will be the thermal efficiency factor is the 0.8. Thermal efficiency factor is 0.8. The heat input will be average. Next, MIG, the welding process number is 131. MAG, the welding process number is 135. The thermal efficiency factor is 0.8. It gives average heat input, but a MAG spray transfer, it gives highest heat input. Okay, FCAW is the 136. This is the welding process number. The thermal efficiency factor is 0.8. It gives average heat input. TIG, it's a 0.6 low heat input because of the thermal efficiency factor value is low compared with the previous other welding process. So it's a low heat input, low productivity, and a low hydrogen process also. TIG is the low hydrogen process. FCAW is the highest hydrogen process. TIG is low heat input and low hydrogen process. FCAW is high hydrogen process. FCAW, flux core arc welding, is the high hydrogen process. MMA cellulosic is the highest hydrogen process. MMA, if you are using cellulosic filler wire means that is high hydrogen. So low hydrogen, which is low heat input, which is high heat input, which is high hydrogen. So we can expect the question like this. So you should know the answer. TIG 141 is the low heat input and low hydrogen process. FCW is the high hydrogen process. SAW is the high heat input process. MMA cellulosic is the highest hydrogen process. Clear? So can I go the next slide? Okay, listen. Actually, we can expect at least one question in technical. In technical, we can expect the one question to calculate the arc energy and the heat input. Okay. This is the question. The weld using the MAG welding process under the following welding conditions. The voltage they given 24, ampere is 240, travel speed or ROL, it's a 300 per minute, 300 mm per minute. So we have to convert into seconds. So for converting the second, we have to divided 60. So 300 divided by 60, it will be 5. Okay, so 24 multiply 240, 300 divided by 60 multiply 1000. If you are doing like this means you will get the arc energy. The value is 1.2 kilojoule per mm, and we have to multiply with your arc energy, thermal efficiency factor. The thermal efficiency factor is 0.8 for MAG. Sometimes They will not give mag directly. They will give the welding process number. So that times you should know what is the welding process. Okay, so the welding process numbers are very important. So the heat input is mainly influenced by the travel speed. So we can expect at least one question. So by for heat input calculation. Okay, listen. The welding position we already discussed in previous chapter. Welding position. Okay. So flat 1G. The PA is the flat 1G. 3G is a vertical down in 3, and then PG is a vertical down. PF is the vertical up, and then PE is the overhead. PB is the horizontal vertical fillet. PC is the horizontal. PD is the horizontal vertical overhead. PE is overhead. Okay, the positions are very important. Next, come here. Okay. We studied the traverse speed is the mainly influenced by the heat input. Okay, the heat input is mainly influenced by traverse speed. We studied. Okay, the traverse speeds are influenced by welding position and welding process. Okay, the welding position and the process have major influence on the traverse speed. Welding position and the process are major influence on the traverse speed. Clear? The heat input is influenced by the traverse speed. The position and the process have major influence on the traverse speed. For example, vertical up PF. Vertical up PF progression tends to give highest heat input because of excessive weaving and forward travel speed. In vertical up, we have to do weaving excessively and we have to do the welding in forward direction. So we can expect the highest heat input. So highest heat input means hardness will be increase, toughness will decrease in the HA jet. Okay, not in the weld metal. This metrological affects on only in the HA jet. Vertical down PG is the lowest heat input because of the fast travel speed. But the thing is, the vertical down gives lack of fusion and penetration problem in position wise. So vertical down gives lack of penetration and lack of fusion problem in position wise. To avoid this type of problem, we have to switch to vertical up. We have to switch to vertical up, or we have to use deep penetrating filler metals, deep penetrating arc filler metals. So the cellulosic gives deep penetrating arc. So if you use cellulosic means we can avoid the lack of penetration and fusion problem in vertical down welding. Generally pipelines we have to do cellulosic. We have to use cellulosic. Okay, let's briefly we will study in the MMA. Okay, horizontal vertical PB. Horizontal vertical PB. It's the low heat input position. Low heat input position because the welder cannot view weaving, cannot do weaving in this position. The welder cannot do weaving in this position. Okay, overhead PE, it gives low heat input process. Sorry, it gives low heat input position. It gives low heat input position because of low current and a relatively fast travel speed, and we are using small dia of electrodes. We are using small dia of electrode in overhead. Okay, welding in the flat position, down hand PA, the heat input low or high is the welder has the flexibility about the travel speed. It's about the welder. Okay, of the arc welding process, SAW is the highest heat input welding process. Welding process wise, SAW gives highest heat input because thermal efficiency factor is 1. Because the thermal efficiency factor is 1. TIG and MIG can produce very low heat input, but TIG is low heat input welding process and low productivity also because the thermal efficiency factor is 0.6. The typical heat input values for controlled heat input welding tends to, this value is very important, This heat input rate, the value is for common for all welding process. Common for all welding process. The heat input value should be 1 to 3.5 kilojoule per mm. But in practically it will be vary, but theoretically, so it should be 1 to 3.5 kilojoule per mm. It's common for all welding process. Okay. Next, listen. Arc voltage. Arc voltage will vary depends upon the welding process. Arc voltage will vary depends upon the welding process. Okay. What is the purpose of arc voltage? The purpose of arc voltage is to maintain the arc. The purpose of arc voltage is to maintain the arc. Okay. The arc voltage is related with arc length. For example, if your arc length increase, what is arc length? The arc length or arc gap both are same. Arc length, arc gap both are same, which means the tip of the electrode to workpiece. The gap between the tip of the electrode to workpiece. The gap between the tip of the electrode to workpiece. This is the arc gap or arc length. Okay. So the arc length increase, arc voltage will increase. The arc length, arc voltage are directly proportional. Arc voltage, arc lengths are directly proportional. Arc voltage, arc length increase, arc length increase, arc voltage will increase. Arc length decrease, voltage will decrease. In manual welding, the welder has to control the arc length. In manual welding, welder has to control the arc length. Okay. The arc voltage is related to arc length. Arc voltage is the purpose of arc voltage is to maintain the arc. The voltage setting will affect the profile of the weld. If you are set the voltage is wrongly, means it will affect your profile, shape of the weld. It will affect the shape of the weld. Okay. One more thing, where you will measure the accurate arc voltage. Where you will measure the accurate arc voltage means it's nearby the arc. Because of the variation in the arc length, there is chances to changes in the arc voltage. To measure the accurate arc voltage, is we have to place our clamp meter is nearby the arc. It's the nearby the arc. So we can measure the accurate arc voltage is nearby the arc. So we can expect the question where you can measure accurate arc voltage is nearby the arc. Okay. As the welding current rises, the voltage also needs to be raised to spread the welded metal and produce the wider and flatter deposit. For MIG-MAC, arc voltage has major influence on the droplet transfer. Yes, the MIG-MAC has three mode of transfer. For example, it has tip, pulse, spray. These three mode of transfers is based on your arc voltage. Is based on your arc voltage. For example, tip transfer, it requires less than 24 welding voltage, arc voltage. Tip transfer is require less than 24. Spray is require more than 24. Spray is require more than 24. Pulse is in between the tip and spray. Okay, so we will study briefly in MIG-MAC. Okay, let's come to the welding current. Welding current, the welding current has a major influence on the depth of fusion and penetration. Your fusion and penetrations depends upon your current. If you are giving more current, high current means you will get good fusion and excess penetration. If you are giving less current means we can expect the lack of fusion and lack of penetration problems. Okay, as a rule, higher current, greater penetration depth. Penetration depth affects the dilation of the welded deposit by the barren metal, and it is particularly important control the dissimilar metals or joint. When you go to joining dissimilar metals, if you are using high current means it will be the big problem, because what is the dissimilar metals? Your base metals are different composition, different chemical and mechanical properties. For example, the base metal, your base metal, parent metal 1, parent metal 2, there is different base metals. The melting temperature of the base metal will vary. If you are using high current means, for example, base metal 1 450, base metal 2 600. So in these cases, it will be the problem material. Okay, so we have to take more care when you go for dissimilar metals. So it will affect the dilution of the penetration. What is dilution? The dilution means before melting, the material will become red hot stage. Before melting, the material will become red hot stage. That is the dilution. Okay. Next, let's go to polarity. Polarity. Polarity determines whether most of arc energy heat is concentrated at the electrode surface or surface of the parent material. The polarity means where the most of the heat is concentrated. Okay. There are very important this table. This table is very important. We can expect at least one question from this table. Okay. Okay. Listen. If you are using DC positive, these concepts are common for all welding process. The concepts are common for all welding process. What is the DC positive, DC negative, and AC? Okay, the concept means if you are using DC positive, means the 70% of the heat at electrode. DC positive means electrode positive. Electrode positive, workpiece negative. So the 70% of the heat at electrode, 30% of heat at workpiece. Okay, this concept is common for all welding process. Okay, if you are using DC negative, the 30% of the heat at electrode, 70% of the heat at workpiece. The AC is 50% of the heat at workpiece, 50% of the heat at electrode. Okay, this concept is common for all welding process. Let's come. If you are using DC positive in MMA means what will happen? Okay, if you are using DC positive in MMA means it gives good penetration, greater penetration, and it gives less deposition. Please take a notes. There is no less deposition. Please write it. Best DC positive gives good penetration and less deposition. Okay, in DC negative, we can expect the less penetration and more deposition. DC negative gives less penetration, more deposition. This is for only for MMA. Okay, AC not suitable for some electrodes. We can avoid the arc blow. To minimize the arc blow, it's AC. Actually, what is the arc blow? Listen, what is arc blow? It's an irregular width. What is arc blow? It's an irregular width. Listen, the arc blow means if I am using DC, okay, I am doing welding here without knowing, without my knowledge, my hand will move here because of the magnetic force. So you know in NDT, MPI, in NDT, magnetic particle testing, DC gives more depth. Up to 6 mm we can detect in DC. In AC we can detect 3 mm. The magnetic strength of the DC is high. Magnetic force of the strength DC is high. So because of the magnetic force, the weld width will go for irregular width. Okay, that is the arc blow. Okay, so to avoid the arc blow, we have to switch to AC. So DC gives arc blow, so we have to switch to AC to avoid the arc blow. Clear? Okay, next come to TIG welding. TIG welding, DC negative rare. Sorry, DC positive is very rare. DC positive is rare because of tungsten overheating. If you are using DC positive in TIG welding means the electrode will goes to overheating, and when it and the electrode will break, and then it will enter into the weld pool. It will leads to tungsten inclusion. So that's why DC positive we are not using in TIG welding. Okay. DC negative is for all steels. DC negative is for all steels. DC negative is for all steels. DC negative is for steels. DC negative is for steels. AC is for alloys. Very important. AC is for alloys. Steels DC negative, AC is for alloys. Very important. Used for all metals except alloys. In DC negative, AC is for alloys. Okay. Next, GMAW, MIG-MAG solid wires. 9:30. Okay. GMAW solid wire MIG-MAG. GMAW solid wire MIG-MAG. DC positive we are using. So MIG-MAG is DC positive. DC negative is rare. AC is never. AC is never. So MIG-MAG is DC positive. Okay. FCAW, commonly we are using DC positive. DC negative is some positional basing, and then AC is never. Okay. SAW is same like MMA. SAW same like MMA. Best penetration, less deposition, less penetration, higher deposition to avoid the arc flow. And gladding operation also. Gladding operation, what is the gladding operation? Any idea? In the tank, okay, to protect the wall thickness from the corrosion. In the tank, we are doing welding on the surface 3 mm or like this. If you are doing welding, if you are doing coating by using welding means, it will protect your wall thickness of the tank from the corrosion. Understand? So it will increase the life of the tank or vessels. So that is the cladding operations. Okay. So clear, Karthik, how do you feel? It's okay?
Yeah, it's okay. Yeah, okay, continue.
Okay, next, open circuit voltage. Open circuit voltage, the purpose of open circuit voltage, the open circuit voltage is common for all welding process. Arc voltage will vary is based on the welding process. Open circuit voltage is common for all welding process. The purpose of open circuit voltage is to initiate the arc. The purpose of open circuit voltage is to initiate the arc. Where you will measure the open circuit voltage? The output terminal of the equipment, the output terminal of the power source. The open circuit voltage, the range should be 50 to 90. The open circuit voltage, the range should be 50 to 90. It should not go more than 90 or more than 100. If it goes more than 100, means it will leads to fatality. Fatality means it will leads to shocking, electrical shocks. Okay, so the range should be 50 to 90. This is for common for all welding process. The purpose of open circuit voltage is to initiate the arc. Okay, and then if you have to use low open circuit voltage for safe operations. Okay, there are two type of power source characteristics are there. There are two type of power source characteristics are there. One is constant current and another one is constant voltage. Okay, the one is constant current and another one is constant voltage. Okay, the first one constant current power source. The first one is constant current power source. The another name of constant current power source, its name is called drooping characteristics. The another name of constant current is the drooping characteristics. Okay, the constant current means manual weldings. The constant current power source is manual welding. So manual welding process, or we can say, is MMA 111. GTAW TIG is 141. Okay. Okay. The welder sets the current and the power source. In manual welding, welder sets the current and the power source. Okay. And SAW more than 1000 ampere. SAW, if you are doing FCW welding with more than 1000 ampere, means that is also is constant current. More than 1000 ampere SAW, please take a notes. SAW more than 1000 ampere also is constant current. SAW more than 1000 ampere also is constant current or drooping. Okay. In this manual weldings, the welder sets the current and the power source. The arc voltage is controlled by the arc length. In manual welding, the arc lengths are under manual control. Arc lengths are under manual control. So because of the hand movement, there is changes in the arc voltage. Because of the hand movement, there is changes in the arc voltage. That's why the welder has to set the current on the power source in this type of welding, in manual welding. Okay. For example, if it's the two arc length is too high means arc length too high means arc will extinguish because the arc voltage will be high. If the arc length is short means the arc length short means the electrode will stub into the base metal. Okay, so the arc will extinguish and then arc voltage will be 0. Okay, let's come to the chart. You will understand. Okay, see the vertical is the arc length, arc voltage variation. Vertical is the arc voltage variation. The horizontal is the current. In this constant current in MMA and GTAW and SAW more than 1000 ampere, the welder set the current at Y. The welder sets the current at Y, and at the time the voltage is in B. Voltage is in B. Because of the hand movements, if you increase the welder increase the voltage, sorry, if you welder increase the arc length, means the voltage will goes to A, and then the current will goes to drop to X. And if the welder, because of the hand movement, the welder is reduce the arc length to C means the current will goes to Z. Anyway, the welder has to work within the fairly narrow range. For example, if the welder increase the arc length above the A, which will increase the arc voltage, which means how the arc voltage will increase because of the arc length increase. If the welder increase the length above the A means the arc will extinguish, the welding will not continue. If the welder is decrease the C means the electrode will go and stub into the base metal, so the welding will not continue. So anyway, the welder has to work within the fairly narrow range A to C. Understand? So this is the concept. The curves are drooping shape. So is the another name of constant current is drooping characteristics. Clear? So MMA and GTAW, SAW more than 1000 ampere, it's a constant current or drooping characteristics. Okay. Next, constant voltage. Constant voltage, constant voltage power source. Okay. Why it's a constant voltage? Mig-Mag, FCAW, SAW less than 1000 ampere. SAW less than 1000 ampere. If you are using less than 1000 ampere in SAW, that is constant voltage. Okay. We can say Mig-Mag, FCAW, SAW, this type of welding process are semi-automatic or automatic. Semi-automatic or automatic. For example, in semi-automatic welding, the R gap is constant. R gaps are under machine control. And wire feed rates are also machine control. R gap, wire feed rates are machine control. And the travel speed, if it's semi-automatic, I'm saying about the semi-automatic. In semi-automatic welding, R gap, wire feed rate, wire feed speed, these are all under machine control. Travel speed and welding gun position, these are all manual control in semi-automatic. If it's automatic, all the parameters are under machine control. Okay. Here in both the cases, whether it is semi-automatic or automatic, the arc length is constant because under machine control. So arc length constant means arc voltage will be constant. Arc length constant means arc voltage will be constant. That's why this type of welding process, Mig-Mag, FCW, SAW less than 1000 ampere, this type of welding process are constant voltage. Understand? Because of the constant arc length. The another name of constant voltage is flat characteristics. Another name of constant voltage power source is a flat characteristics. Okay. The wire feed speed is related to current. Wire feed rates is related to current. Right. Wire feed rates are is related to current. Okay, listen. Current increase, wire feed rate, wire feed speed increase, burn-off rate maintain the arc length and arc length and voltage. Okay, listen. Come to the chart. Okay, because of the constant voltage, the voltage is because of the constant arc length, the voltage will be constant at B. The welder sets the voltage at B. At this time, the current will be in the Y. Current will be in Y. Because of the feed placement, if the arc length is constant, if the bead placement is, the weld bead placement is, one side is down, one side is up, means that time there is changes in the arc gap. That times there is changes in the arc gaps. Okay, in these cases, if the arc length increase, the voltage will goes to A, the current will drop to X. So if the current is dropped to X, means there is chances for the burn-off rate will reduce, and the wire feed speed also will reduce. So that times the machine will bring the preset value. The machine will bring automatically brings to preset one. Okay, same concept. If the current, if the because of the bead placement, the arc gap is down to C, means the voltage will goes to C, the current will goes to Z. Here there is chances for more burn-off rate, and there is chances for faster wire feeds. So that in these cases the machine will brings to preset values. Okay, because of it's a semi-automatic and automatic. This is the concept. Clear? So constant voltage is finished. Okay, next. Okay, next. Pressure welding. What is pressure welding? What is fusion welding? Okay, fusion weldings are MIG, sorry, MMA, SMAW, MIG MAG, TIG, submerged arc welding, electroslag welding, laser beam welding, electron beam welding. These type of weldings are liquid state welding. Liquid state welding. Liquid state means the filler metals are melting and it is a liquid state welding. Okay, forge welding, friction welding for dissimilar metal. Okay, resistance welding. These type of weldings are plastic stage welding. Plastic stage welding. If I heat this one, it will melt, and then if I give some pressure, means it will join. So this is the plastic stage welding. That type of joints are plastic stage welding. So that type of weldings are forge welding, friction welding, resistance welding. Clear? Okay, next. MMA, we can do welding above 3 mm all position, all metals. TIG up to 10 mm, particularly high integrity, high quality joints we are using TIG welding. Usually best for toughness and corrosion resistance. MIG MAG FCAW typically 3 to 30 mm. SAW is 15 mm and more than 150 or above. These are all summaries. Steel, all the process steels we can do with all welding process. The reactive metals very important: aluminum and titanium, copper. Aluminum reactive metals, light alloys. This TIG, inert gases. Aluminum and titanium, copper. This type of reactive metals are we have to do welding only with inert gas welding. So inert gas means TIG and MIG. TIG is the tungsten inert gas welding. MIG is the metal inert gas welding. Okay. So MMA, TIG, MIG, MAG, all position. MAG spray transfer is PA, PB position only. MAG spray transfer we can do only PA and PB position only. Okay. So SAW also is PA position, flat position. MMA drooping constant current we can do DC positive, DC negative, AC. MIG MAG we can only DC positive. TIG DC negative is for steel, AC is for alloys. MAG FCW flat is a constant current, constant voltage. DC positive and DC negative. MIG MAG only DC positive. Submerged arc welding is a DC positive, DC negative, and AC also we can do. Okay. So next, okay, I'll finish. Okay, any doubts in this chapter from this chapter? So Javed, any doubt?
Yes, actually, so many technical points inside. So
Yeah,
I
please.
think I have to study. I mean, well, I mean, I have to read well. Okay, some of the points still, I mean, cannot properly not understand, but no problem. I can manage
Properly understanding
after.
means it's my teaching or
No. It's okay. Your teaching is okay, no problem. But suddenly to understand, so I have to read again one more time. No problem. It's okay. Continue.
yeah. Today which two chapter is finished.
Okay.
So how
Hello?
do you feel? You said the last one, the previous chapter. You see
Hello?
the terms and definition. I was very fast. So okay. Now how do
No,
you
no,
feel?
it's okay. It's okay. No, it's okay. Only the welding process, the last stage, the DC
No, this
positive, AC negative. Only that section only we need to be. I mean, I need to be a little bit
No
more
problem. We can
to be
we can
understand.
discuss.
Yeah.
If you have any doubt, means we
Yeah.
can discuss now. Karthik.
yeah. Actually, that the process you told, right? Spray arc, dip, and pulse.
Yeah.
What about short circuit?
Short circuiting is the tip. Short circuit is another name of
Tip,
is the tip. We will discuss. In Migmac we will discuss about these things fully.
okay.
Short circuiting is the tip.
No,
Tip
actually,
is
the
short
tip
circuit.
is replaced with short circuit. The latest version is short circuit only.
Actually, your voice is not clear. It's very low. Your voice is very low.
Okay, actually the dip name is replaced by short circuit. Latest version they changed, I think.
No. Yes, see, the tip transfer is the low heat input because it's a
Yeah,
less than
low
24
current,
kV
yes.
voltage.
24,
Okay, but the tip gives a lack of fusion problem. We can use only position and all position we can do for root pass.
No, okay, that I understand. What I mean, the another name is short circuit, right?
Short circuiting tip transfer. The word is the short circuiting tip transfer.
Okay,
The another name is short circuiting. The another name is a tip.
okay.
Understand?
Yeah, okay.
Okay. So what, see, Mr. Javit, you try to ask something about the table. Can I go again?
No, not actually the table. After the chart, the graph.
Graph. Okay, which is the constant voltage or constant current?
Yeah, the page number 9. Yeah.
Which one you need? Which one I have to go? Constant voltage or current?
Ninth page. Yeah.
Sorry?
Ninth page.
Mag.
Yes.
No, page
Ninth,
number 9.
ninth page number 9.
Okay, it's a constant current.
This is constant current. Okay.
Yes. Okay.
Okay.
See,
No. Page number 10. Yeah. Okay. Yes. Tell me.
page number.
Yeah. I mean, actually, page number 8, 9, 10, and 11.
Okay, listen.